Artificial intelligence is no longer a futuristic concept. It's woven into the fabric of our daily lives and industries in ways that are transforming how we work, create, heal, and even govern. In 2025, AI has advanced far beyond simple chatbots or recommendation engines. Today, it generates art and movies, designs new medicines, writes software, drives vehicles, monitors the environment, and even helps predict financial markets. But to truly appreciate how powerful and disruptive AI has become, it's important to look under the hood. Each major domain, whether it's healthcare, finance, education, or creativity, being reshaped not only by what AI does, but by the specific technologies that make it possible, from deep learning and diffusion models to reinforcement learning and even quantum computing. In this breakdown, we'll explore 12 key areas where AI is making the biggest impact in 2025. For each one, we'll dive into the technical mechanics behind how it actually works, real-world applications showing where it's already in action, the challenges and debates that come with adopting such powerful tools. By the end, you'll see not just what AI is changing, but how it's doing it, why this matters for our future. 12 AI influence areas for 2025, unpacking not only the breakthroughs, but also how they work, where they're applied, and what challenges they face. 1. Generative AI for content creation, how it works. Generative AI uses large language models, LLMs, and diffusion models for image video to create text, music, or visuals. These models are trained on massive datasets and can mimic styles, genres, or even specific artists. Applications. Film TV studios are experimenting with AI-generated background characters, dubbed voices, and pre-visualization storyboarding. Journalism. AI tools draft reports and summaries in seconds, though editors still check for accuracy. Advertising. Campaigns can instantly generate hundreds of variations of ad creatives optimized for different audiences. Challenges. Intellectual property. Who owns AI-generated works? Misinformation, deepfakes, and ethical use. 2. AI in healthcare, drug discovery. AI reduces drug development time by simulating molecular interactions instead of expensive lab testing. AlphaFold, by DeepMind, mapped protein structures, a Google Maps for biology, now being applied in pharma pipelines. Diagnostics. AI tools, like PathAI and Arteries, analyze medical scans with accuracy rivaling human experts. Example. AI detecting lung cancer nodules on CT scans at earlier stages. Challenges. Regulatory approval, integration into hospital workflows, and data privacy. HIPAA, GDPR. 3. Generative AI for software development, how it works. Code generation models like Codex are trained on public GitHub repositories. They use natural language prompts to generate functions, test cases, and documentation. AI debugging systems that trace errors and suggest patches. Low-code to no-code platforms that let non-engineers build apps via natural language. Challenges. Security risks. AI may suggest vulnerable code. Licensing. AI trained on copyrighted codebases. And over-reliance by junior devs. 4. AI in autonomous vehicles. Levels of autonomy. Level 23. Driver assistance. Tesla, Mercedes. Level 4. Full autonomy in limited environments. Waymo in Phoenix. How AI works. Computer vision LiDAR radar fuse to understand the environment. AI predicts pedestrian and vehicle behavior in real time. Challenges. Safety validation, liability in accidents, regulatory hurdles, and public trust. Traffic optimization. AI-driven systems use camera feeds and traffic sensors to reduce congestion dynamically, already deployed in Singapore and Los Angeles. 5. AI in personal assistance. Advances. Instead of command-based assistance, AI now supports conversational context, e.g., asking about yesterday's weather, then comparing to today. Integration with productivity apps, calendar, emails, docs, allows them to act like real executive assistants. Emotion recognition uses prosody analysis, tone, pitch, stress, and facial recognition to infer emotional states. Example: a call center bot detecting anger and routing to a supervisor. Challenges: privacy concerns. Emotional data can be sensitive if misused. 6. AI in environmental science, climate modeling. AI speeds up simulations of ocean currents, atmospheric chemistry, and deforestation patterns. Google's Earth Engine AI predicts wildfire spread and flood risks. Wildlife monitoring. AI-powered drones identify species in real time, helping conservationists fight poaching. Acoustic AI detects endangered species, like whales, from underwater recordings. Challenges: data availability in developing nations. Ethical concerns around surveillance. 7. AI in finance. Algorithmic trading. Hedge funds use reinforcement learning to execute trades in milliseconds. AI can detect correlations humans miss, e.g., weather patterns affecting crop prices. Fraud detection. AI analyzes transaction histories to detect anomalies, e.g., a sudden overseas purchase. Machine learning models evolve faster than traditional rule-based fraud detection. Challenges: black box decision-making. Regulators demand explainability. Bias. AI may unfairly flag low-income customers. 8. Ethical AI regulations. Global regulation. EU AI Act, 2025. First comprehensive AI law, classifying applications by risk, low versus high risk. U.S. Sector-specific regulation. Finance, healthcare, military AI. Bias mitigation. Techniques like adversarial debiasing reduce discrimination in models. AI audit companies are emerging, ensuring fairness in hiring algorithms, credit scoring, etc. Challenges: international alignment. Countries differ on what responsible AI means. 9. AI in arts creativity. AI art. Tools like DALL-E, Midjourney, Stable Diffusion produce hyper-detailed visuals. Artists now use AI as a co-creator to spark inspiration or build drafts. AI in fashion. Virtual try-ons with generative avatars, used by Zara, Nike. AI predicts fashion trends by scraping social media, analyzing influencer content. Challenges: copyright lawsuits. Artists suing over AI using their styles. 10. AI in education. AI tutors. Adaptive learning platforms, like Conmigo, Duolingo AI, adjust to student pace. AI tutors explain mistakes step by step, unlike static textbooks. Applications: AI-generated practice questions for math coding, essay feedback with grammar, coherence, and style analysis. Challenges: over-reliance on AI. Students may skip critical thinking. Unequal access in poorer regions. 11. AI in law governance. Legal research. AI scrapes thousands of case laws in seconds. Tools like Harvey AI are used in law firms. AI predicts litigation outcomes with probability scores. Contract review. AI highlights risky clauses in contracts, e.g., automatic renewal traps. Predictive policing. Algorithms forecast crime hotspots, but critics argue they reinforce racial profiling if trained on biased historical data. Challenges: transparency, accountability, and judicial acceptance of AI opinions. 12. AI in quantum computing. Quantum machine learning, QML. Quantum computers solve optimization problems, logistics, drug molecules, faster than classical ones. AI helps design quantum circuits by reducing noise and errors. Startups applications. Startups like Rigetti, IONQ, Xanadu, merging AI with quantum for finance and pharma. Use case: optimizing supply chains under uncertainty. Quantum beats classical AI in scale. Challenges: quantum hardware is still limited, few hundred qubits, prone to errors. Widespread impact is likely late 2020s. Each of these areas is progressing at different speeds. Mature and widely deployed now. AI in finance, healthcare imaging, generative content, software development. Emerging but experimental. AI quantum, fully autonomous vehicles, predictive policing. High societal debate. Ethical AI, Regulation, AI art ownership. Let's dive into the technical underpinnings and practical applications across all 12 areas of AI influence. I'll present it in a clear, structured way for depth and clarity. 1. Generative AI for content creation. Technical mechanics. Text, transformers, LLMs, predict the next word using attention mechanisms over large data sets. Images, video. Diffusion models start from random noise and iteratively denoise to create coherent images. They learn the probability distribution of pixels conditioned on a text prompt. Audio, music, neural vocoders, WaveNet, Hi-Fi GAN, generate realistic speech or music from spectrograms. Real-world example, Runway Gen 3 text-to-video generation for ads and short films. YouTube, TikTok creators using AI avatars to scale multilingual content. 2. AI in healthcare. Technical mechanics. Protein folding. AlphaFold uses deep learning to predict the 3D structure of proteins by learning spatial constraints. Diagnostics. CNNs, convolutional neural networks, detect patterns in X-rays, MRIs, and CT scans. Drug discovery. Reinforcement learning optimizes candidate molecules by predicting binding affinity to targets. Real-world example. In silico medicine, AI designed drug for pulmonary fibrosis, entered clinical trials in 2024. Butterfly IQ AI-powered handheld ultrasound device. 3. Generative AI for software development, technical mechanics. Transformer-based coders, trained on billions of lines of code, predict functions, signatures, loops, and even APIs. Automated testing. AI fuzzing tools generate thousands of test cases and simulate edge cases. Debugging. AI models analyze compiler errors and logs match against patterns from training data. Real-world example. GitHub Copilot X now explains code in plain English and auto-writes documentation. Replit Ghostwriter AI IDE that suggests code completions in real time. 4. AI in autonomous vehicles. Technical mechanics. Perception. CNN's LiDAR interpret objects, lane markings, pedestrians. Prediction. Recurrent models forecast trajectories of cars, pedestrians. Decision-making. Reinforcement learning agents optimize driving maneuvers under constraints. Real-world example, Waymo running fully driverless taxis in Phoenix, San Francisco. Tesla FSD V12 uses end-to-end neural networks, camera input, steering control, instead of modular pipelines. 5. AI in personal assistance. Technical mechanics. Context memory. LLMs now use retrieval augmented generation, RAG, to remember previous conversations. Emotion recognition. ML classifiers analyze MFCC, MEL frequency cepstral coefficients, in voice for tone emotion. Action orchestration. Agents link LLMs with APIs to complete tasks. Book flights, summarize emails. Real-world example. Microsoft Copilot integrated into Office edits Word docs, analyzes Excel sheets conversationally. Amazon Alexa 2025 update proactive planning, e.g., suggesting you leave earlier if traffic is heavy. AI in environmental science. Technical mechanics. Climate modeling. ML surrogates replace slow physical simulations 1000x faster predictions. Remote sensing AI CNNs detect deforestation or crop health from satellite imagery. Acoustic AI RNNs classify animal calls in noisy recordings. Real-world example. Google Flood Hub AI predicts riverine floods up to 7 days in advance. Wildbook AI identifies individual whales, turtles, zebras from photos to track populations. 7. AI in finance. Technical mechanics. Trading. Reinforcement learning agents maximize long-term returns by trial and error simulation. Fraud detection. Graph neural networks, GNNs, detect suspicious relationships in transaction networks. Risk management. ML models stress test portfolios under hypothetical scenarios. Real-world example. JP Morgan LOXMAI execution system optimizing large trades. Visa MasterCard real-time fraud detection with AI, cutting false positives. 8. Ethical AI regulations. Technical mechanics. Fairness metrics. Statistical tests like demographic parity, equalized odds measure bias. Explainability. Tools like SHAP, Lime Highlight, which features drove an AI decision. Real-world example. EU AI Act, 2025. Bans real-time biometric surveillance, enforces audits for high-risk AI. NIST AI Risk Framework. U.S. Voluntary Guidelines for Responsible AI Adoption. 9. AI in Arts Creativity, Technical Mechanics, Style Transfer, Neural Nets Blend Styles, e.g. Van Gogh Photo. Fashion Design, GANs, Generative Adversarial Networks, propose new clothing styles from trend data. Text to 3D, diffusion nerfs, neural radiance fields, generate 3D objects for games AR. Real-world example, Louis Vuitton Balenciaga AI assisted virtual fashion shows. Mid-Journey V6 photorealistic ad campaigns generated without human photographers. 10. AI in education. Technical mechanics. Adaptive learning. Reinforcement learning adapts difficulty level per student. Knowledge tracing. Bayesian models predict how likely a student is to recall concepts. Essay evaluation. LLMs fine-tuned on grading rubrics give feedback. Real-world example. Conmigo. Khan Academy. AI, tutor that solves problems step by step. Duolingo Max conversational AI for language practice. 11. AI in law governance. Technical mechanics. Legal NLP. Transformers fine-tuned on case law. Retrieve relevant precedents. Contract review. Named entity recognition, NER. Extracts obligations, risks, dates from contracts. Litigation prediction. ML classifiers trained on court outcomes estimate win probabilities. Real-world example. Harvey AI, adopted by PwC for contract analysis. Do not pay AI lawyer generates legal documents and negotiates refunds. 12. AI quantum computing. Technical mechanics quantum ML. Quantum circuits act as feature transformers, capture complex correlations classical ML can't. Hybrid AI, classical AI handles pre-processing. Quantum circuits handle optimization subtasks. Real-world example, IBM Quantum MIT Quantum AI, model for material science simulations. IonQ Goldman Sachs, exploring quantum AI for financial risk optimization. Big picture, now, 2025 mainstream. Generative AI, finance, healthcare imaging, AI tutors, Copilot-like tools. Emerging but experimental. Quantum AI, Level 4 autonomy, predictive policing. Hot debates, AI art ownership, bias in finance law enforcement, privacy in emotion recognition. Artificial intelligence in 2025 is no longer an experimental technology reserved for labs or niche application sets, a driving force across nearly every sector of society. From designing life-saving drugs and accelerating climate science, to reshaping education, finance, and even the arts, AI is acting as both a creative partner and a problem solver. At the same time, it raises profound questions about ethics, ownership, fairness, and trust. The common thread running through all these breakthroughs is speed and scale. AI enables us to process more data, generate more ideas, and simulate more possibilities than ever before. But its growing influence also demands thoughtful regulation, transparency, and human oversight to ensure these tools serve society responsibly. As we stand in 2025, one thing is clear. AI is not just changing how we work and live, it's redefining what's possible. The challenge ahead is not only to keep up with its rapid evolution, but also to shape it in ways that align with human values and global needs.